So if I want to represent a vector which represent this position, so what will be the position vector? So I have moved 3 units in x direction, 4 units in y direction, and 5. Yeah. So what would be my position vector? 3 units in x direction, right? Plus 4
There's 4
units.
units in J direction and then 5 units in K.
Right. So this would be my position vector. Okay. Understood, Nabila?
Yes.
So these I, J, and K are called the universal unit vectors. Okay, understood. Understood, Nabila?
Yes, yes.
Yeah. So this I represents one unit or the direction of x, and this J represents the direction of y, and this K represents the direction of z. Okay.
Yes.
So whenever I am writing a vector like this, let's say 2i plus 4j and minus 7. Okay. So I have moved 2 units in x direction, 4 units
4
in
units
y,
in Y.
and 7 units in minus of 7 units in minus of z times, right? So let's say that this is your x direction. So what is the minus of x direction?
Minus.
Just remember the coordinates. So you write it like this: 1, 2, 3, 4. And how do you write this one? This is
Minus 1,
minus 2, minus 3. Right. So this is called the minus x direction. The direction opposite to this x direction. Right. So this would be minus x direction. Okay. And let's say this is y direction. So this would be what direction? Yes, Nabila.
Yes.
No, this is y direction. So the opposite to y direction would be what?
Minus 5.
Minus 5, right? And similarly, we have this z direction. So opposite to this z direction, you have
Minus
minus,
Z.
right? Okay, so I'm waiting for Afaf and Rishita, right? So then we can go ahead, Akil, right?
Yes, sir.
So let's wait for them. So this much we did in your class, right, Akil?
Yes, sir.
Okay, then today I will just tell you about the basic definition of this vector quotient, right? What is the equal vector? What is the opposite vector or the negative vector? What is the parallel vector, anti-parallel vector, unit vector? And then we will learn about this addition and subtraction. Okay.
Yes, sir.
Okay, so let's wait for it, right? And give me a moment so that I can have some water. Okay, so Akib, where do you live, Akib?
The mom, sir.
The mom.
Yes, sir.
Yeah, and Nabila, where do you live? Yes,
In Riyadh, sir.
Riyadh. Okay, so how much distance is from Riyadh and Dammam?
Near
I don't,
about 400.
yeah.
400 kilometers.
Yes, sir.
400 kilometers. Okay, so let me ask you guys a very simple question, right? So you guys have done this second chapter, right? So 400 kilometer, and then you are moving in a train, right? Bullet train. So
Yes.
let's say that the speed of this bullet train is 100 kilometer per hour, right? So how much time it will take Akib to reach Nabila's city
Four.
from 4 hours, right? So
Yes.
yeah. So that is why we need this this mechanics chapter, right? The kinematics to understand about these physical scenarios, right?
Yes, sir.
So we can apply these physical scenario in physical world, right? Okay, so this was a very simple question, and yeah. I'm just asking these questions to wait because we are waiting for what Afaf and Rishika. Okay, so maybe Afaf is not there actually because we are trying to connect with Afaf. Okay, so we should start, right? Right. In the meanwhile, she will join, and then what we can do is that we can okay. So now you guys know what are vectors, right?
Yes.
Yes,
So
sir.
you know that vectors are what kind of physical quantity?
Vector.
Yeah, what kind of physical quantity? Vectors are vector, right? So Akib, you know that vectors are vector, but it has a peculiar property, right? Akib, it has magnitude as well as direction, right?
Yes.
So, sir, vector quantity, right?
Has both only.
Yeah, so I was asking that vectors are what kind of physical quantity? Yeah, so yeah, you are
Correct.
right. Vectors are vector quantity. Yes, so you are correct. Vectors are vector quantity. And what are the properties of this vector quantity? Yes,
It has both magnitude and direction.
yeah. So magnitude, yeah. Sorry, you were right. So vectors are vector quantity. So magnitude plus direction. Okay. And let's say you represent a vector like this. Okay. So this is some vector which is A, right? And it has two parts, right? So this is the geometrical representation of vector. And this arrow, so this arrow has two parts. One is this head, okay, and this one is this tail, right, Akim?
Yes, sir.
So this arrow represents this direction. This head of this arrow represents this direction, right? And
Yes.
this length represents this magnitude. Length of the arrow represents this magnitude. Okay.
Yes, sir.
So to represent a vector geometrically, we just draw it like this. So this is some vector. Understood?
Yes, sir.
And so let's say what are the types of vector you have? So types of vectors. The first one is the equal vector. Okay. equal vectors. So let's say you are given a few vectors, and if you want to find out that those vectors are equal or not, so how can you check that? We have to check how many properties of those vectors. Yeah.
Their
Okay.
length,
Yeah, their length and
magnitude.
magnitude is the same thing, right?
So direction.
Direction, right? So to have those vectors to be equal, we need to show that their magnitude as well as their direction is the same, right? So if two vectors have equal magnitude as well as the direction, then those vectors are said to be equal vectors. Okay, so let's say I have some vector A, right, whose magnitude is A and A hat. This is the magnitude, this is the direction, right? And if I have some another vector B, which is B magnitude and this B direction, right?
Yes.
Yes, sir.
So we all know already that we represent a vector like this, right? The magnitude and this represents this direction, right? So yeah, so to have two equal vectors, the first criteria would be that this A is equal to this B magnitude, right? Akil and Namila.
Yes,
Yes.
sir.
And the second property that we need to fulfill is that this A hat should be B hat, right?
Yes, sir.
So
Yes, sir.
if these two are the scenario, then this vector A would be equal to this B, right?
Yes, sir.
Right. So let's say that I have drawn two vectors, which is okay, draw this. So this is one vector, right? And this is the other vector. Okay. And let's say this is A and this is B. And let's say we have this vector A and this vector B. Right. And let's say I have this vector A and this vector B. Okay. So by looking at these figures, so is this A vector equal to this B vector? Okay.
No, sir.
Why?
Because the length of the B is greater.
Let's say that this is the same. So this is looking like the same one, right? The lengths
Okay,
are
then
the
it is
same.
equal.
Then it is equal. Just check again. Check again, sir. Okay. Think again. Yeah, Nabila, what is your answer? Is this
Not
vector equal?
equal, maybe.
Yes,
Not equal.
not equal. Why is that, Nabila?
Because of the direction. Maybe.
Right. Yeah. So this vector has this direction, right? This
Yes.
vector has this direction.
Yes.
Right, Akil?
Yes, sir.
So these two vectors will not be equal because they have not same direction. Okay.
Yes.
And what about these two vectors? So is this vector, are these vectors equal? A and B?
Magnitude is not equal.
Yeah, magnitude, direction is same, right? Direction is same, but this magnitude is not. So this length is unequal. So this is not. And by looking at this figure, these figures, we can say that direction and the magnitudes are equal. So these vectors are equal. Did you guys understand this part?
Yes, sir.
Yeah, so please note this down, right?
Okay,
So
sir.
from now onwards, we will be noting all these information that we are doing, right? Whenever you guys finish noting, please tell me, then we can start the next one.
Okay, sir.
Yeah, so always remember that this head represents this direction, right? So we have to
Yes,
think
sir.
about this head and this length.
Yes, sir. Finished, sir.
Finished?
Yes, sir.
Yeah, Nabila, you done?
Yes, sir. Done.
Okay, so the next type is the opposite vectors. Okay, so or the negative vectors, not the opposite, but the negative vectors. So negative vectors. So when two vectors are equal in magnitude. Yeah, what happened again? When two vectors are equal in magnitude but opposite in direction, then those vectors are said to be negative vectors. Okay, so let's say I write one vector which is a vector like this, right? And the other vector which is this. Okay, so this has same length. Right, these vectors have same length, but the direction is opposite. Right.
Yes, sir.
So let us write it mathematically that these vectors, the first situation is that A magnitude is equal to this B magnitude, right? And the direction of this A hat is negative of this B hat. Okay. Understood, guys? So let's say,
Yes, sir.
yeah, so this direction is A hat, and this direction is minus A. Right, guys?
Yes, sir.
Yes,
So
sir.
then these two will be called the negative. Okay, so let us again understand this diagram. So you have these figures. Let's say this is vector A. Okay, and this is vector B. Right, and let's say you have these vectors A and this vector B. Right, and let's say you have this vector A and this vector B. Right. So are these negative vectors?
Yes,
Yeah.
sir.
Yeah. So negative vectors. Correct answer. Because the magnitude is equal and the direction is opposite. And what about these? So are these negative
Equal
vectors?
vectors, sir.
Equal vectors. Yes. Correct. Correct. And what about these?
Not equal, sir.
Yeah. So not equal and not the negative vectors. Yeah. Right. So you guys just quickly notice. Okay.
Okay, sir.
Done.
Yeah.
Finish, sir.
Yeah. So the next topic is, or the next type is this opposite or the parallel vectors. So we have this parallel vectors. So when two vectors have same direction but different magnitudes, then those vectors are called parallel vectors. Okay, so let's say you have this vector A, right, and then you have this vector B, right? So we
Yes,
can,
sir.
yeah, so we can see that the direction, the head is the same, right?
Yes, sir.
But this magnitude is different. Okay, so these are
Parallel
the
vectors.
parallel. Okay, so how mathematically we can represent this? So A magnitude is not equal to B magnitude, right? But this A hat is equal to this B. Okay.
Yes, sir.
Yes, sir.
Okay. So diagrammatically you can figure out, right? So yeah. So just note it down, and then the next last step we will understand.
Finish, sir.
Finish, Nabila, finish.
Yes, sir.
Yeah. So the next type is this anti-parallel. Okay, so when two vectors have different opposite direction, as well as different magnitudes, right? Then those vectors are called anti-parallel vectors. Right. So this you can see that this anti-parallel vector. So this negative vectors. Okay. So let us first understand about this anti-parallel vector. Then we can generalize this. So let's say this is a vector, right? And this is some b vector. Okay. So these A B's are anti-parallel vectors. Okay.
Yes, sir.
Yes, guys. Yeah. So let's say that this is A magnitude is not equal to B magnitude. And second is that A hat is minus of B. Okay. So
Yes,
these
sir.
are anti-parallel. Okay. So if I say that my A equals to B, so if in some case for the anti-parallel case, when my A equals to B, so that anti-parallel vector would be called what?
Sorry, sir.
Right. So yeah. So let's say that if my for one case of anti-parallel, both the magnitudes of those vectors are equal. So what would be that? What would be those vectors?
Negative vectors.
Right. So the negative vector is one special case of these anti-parallel. Understood?
Yes, sir.
Yes.
Okay. So please note this down and then the last type.
Finish, sir.
Finished. Namila finished.
Yes, sir.
And the last type you guys already. So this is unit vectors. Right, or let's write it as unit vector. Okay, so what would be the definition of this unit vector? Yeah, guys.
A vector which is having unit.
Unit,
Yeah.
1 unit.
1 unit. You can represent a vector by magnitude and direction. So unit means a vector whose what? Yeah.
Magnitude.
So whose magnitude is 1, right? Then it is called a unit vector. Right? It represents the direction of the vector. Right, guys?
Yes, sir.
And so this A hat is a unit vector and A magnitude would be if A hat is a unit vector. Right.
Yes, sir.
Yes, sir.
Yeah, so do you want so you guys want to note this down or you guys know this? You want to know this down?
So there's one more vector, right?
Those one vector?
No, one more vector. Zero vector.
Zero vector. Okay, so let us yeah. So zero vector. Right. So F zero vector. So this signifies that the magnitude of the vector is zero. Right. So A magnitude is zero. Okay. So we can write zero vector in any point. Right? So the magnitude is zero.
Okay, sir.
Yeah. So okay, so this part is done, and you already know that. And then you have these two vectors. So one is this co-initial vector. Okay. So as the name suggests, as the name suggests, that initial meaning the starting point of the vector is the initial point, and then co meanings the same, right?
Yes, sir.
Yes, sir.
Yeah. So when two vectors have same tails, right, or the initial point, then those vectors are called co-initial vectors. Okay,
Yes, sir.
understood,
sir.
guys. So let's say you have these vectors and this vector. So are these co-initial? Are these vectors are co-initial?
Yes.
Yes,
Yes.
Nabila, what do you say?
No.
No, yeah, because details are different, right? So to make it a co-initial vector, we have to take this vector at this point. So these two vectors, right? Let's say A and this B vector. Yeah. So Akil, are these the co-initial?
Yes, sir.
Right. So the starting point should be the same. The tails should be the same, right? So this is a co-initial vector, but
Yes, sir.
this is right.
Yes, sir.
And then you have this co-planar vector. So as the name suggests, what is a plane?
A plane vector straight.
So plane means two dimension, right?
Yes.
Yes,
Plane
sir.
means a surface, right? Right. So what do I mean by coplanar vector? So just see a wall of your room, right? So a wall of your room is some. So let's say that the roof of your room is some plane, or wall of the four walls of your room are some plane, right? So the vectors, if I draw a vector on that wall only, right? So if I if I draw all those vectors on that wall only, so that will be called the coplanar vector. Okay. And if I write one vector and then I write some other vector in this wall, right? So those two vectors would be not planar, right?
Yes,
Understood,
sir.
guys?
Yes,
So
sir.
if the vector is coming out of that plane, right? So let's say this is my plane and the vector is coming out of this plane. I have written this vector in this way, right? So this has a different direction. It is coming out of this plane. So this is a plane and this vector is coming out of this plane. So this vector would not be coplanar of this plane, right? If this vector would be not coplanar. Understood, guys?
Yes, sir.
Yeah. So if you are seeing your laptop and you draw some vectors on that laptop, right? So those vectors would be coplanar. But if you are drawing a vector which is you can't draw, right? So when you are putting some vector which is coming out of that laptop, so that would be not a coplanar. Okay.
Yes,
Yeah.
sir.
Yeah. So when the vectors are in the same way, right? Then those vectors are called coplanar vectors. Understood, guys? So
Yes, sir.
so let me draw one diagram and So did you guys note this down part, co-initial vector part? Did you guys note this down? Yes. Did you guys note this down? The co-initial part.
Yes, sir.
Yes, sir.
Okay. Yeah. So coplanar part. Let's say you have this surface, right? And all the vectors are like this. Right. So these are on this surface only. Okay. And let's say I draw a vector which is like this. Like this. So what does this sign suggest? So you have two signs, right? You have this sign and you have this sign. Okay. So if you are seeing an arrow, so the arrow is this. And this is some arrow. Okay, guys. And if you are seeing the arrow from the front, so how will it look like? Will it be looking like this or will it be looking like this? So you are seeing the arrow from the front. So this is the arrow, right? So this has this part and this has this part, last part. Okay. So you are seeing the arrow from this front. So this is coming at you like this. So how what kind of figure you will see? This
First
one, or
one,
this
sir.
First one, right? Absolutely right. So this is upward or upward, you can say, right? Outward.
Yes, sir.
And this is inward. Right. So when you are looking from the behind, this is not cross, right? This is like this, but let's say the arrow is cross. So we'll see the cross part, right?
Yes, sir.
So this is
Yes.
how, yeah, so this is how you represent the inward or the outward direction, right? So this is showing that this cross is showing that this vector is going where? This cross. Let me draw it here. So this is this, and this is this one is this, and this one is this. Okay, so in this example, you have all the vectors in this board or in this surface or in this plane, right? So in this example, yeah. So in this example, you have all these vectors in this plane, right? So this is the example of coplanar vectors. Okay. But for this case, you have these vectors in this plane, but this cross is going outward or going inwards. This cross.
Inward.
Yeah. So this is going into the plane, right? Into the board or the plane, and this is coming out. Right, so this is not coplanar. Understood, guys?
Yes, sir.
Yeah. So why I was talking about this coplanar vectors and this co-initial vector? Because you define all the operation. So you have this addition, subtraction, and all these operations, multiplication. So you do it with the co-initial vectors. Okay. So first you have to make all your vectors co-initial and then you can define the addition and the subtraction, right? So let's
Yes,
say,
sir.
yeah. So let's say you have a vector which is this, right? And the other vector which is this. So can you define the addition of this vector? No, na?
No, sir.
Yeah, you have to take this vector and take it here so that then you can define the addition and the subtraction. Okay.
Yes, sir.
And so that is why these co-initial vectors are used. And as I've talked about this universal unit vector, right? So as we now know that we can represent the position of any vector, right? Let's say this is point X, point Y, and point Z, right? So we can represent any vector in this form. Let's say this is R. Let me try it. Be careful. Okay, so we can write this as xi hat plus yj hat plus z. Right. Understood, guys?
Yes, sir.
So this is the x. Oh, let me write it as not xyz because this is xyz, but let me write it as, let's say this is 3, 4, 5. So I can write R as 3i plus 4j plus 5. Right. So this represent the x component. Right, guys?
Yes, sir.
Yes, sir.
And this represents this y component. Why I omitted this x, y, z, I will, because that will make it confusing. So I have, right. So this is z component. Yeah. So if I write the position only, then this would be x, y, z. And let's say if I writing the velocity, right? So velocity would be vxi plus vyz plus vz. Right? This would not be xi plus x and yj plus z. Right. So that is why I have just written this part. So you can write any vector as xi plus ryj plus rz. Understood, guys? Or any confusion?
Yes, sir.
Yeah. So a vector you can write in the universal vector form as 3. So this is universal unit vector form, and this is also called the Cartesian. Okay. Understood, guys?
Yes, sir.
Okay. Yeah. So let me write. Let's say that you have this point. Let me write it as. So we have 5 and let's say -3 and 4. So what would be the position vector, guys? Aki, we tell.
Pi I cap plus minus 3 j cap
Right.
plus 4 k cap.
Yeah, absolutely right. So this is the position vector of this point. Okay. Understood. Yes.
Yes, sir.
Understood, Nabila. Hello. Okay. So Nabila got disconnected. When did she get disconnected? Okay. Do you know?
Don't know, sir.
Okay. Okay, so yeah. So should I go ahead and what should I do? Should we wait? So let us wait for 2 or 3 minutes. Okay. Okay.
Okay, sir. Sir, she
Because
came.
then I go ahead and then she can.
Yes, sir.
Yes, Nabila, you got disconnected somehow. Internet not working
Yes.
properly.
Internet issue.
Yeah, internet. So that is the problem, or that is the technical issue that we can face. Yeah. So so at what point you got disconnected?
Then you were asking something, I guess.
Yeah. Yeah. So when I was asking the position vector of this point to Akif, right?
Yes, yes.
Okay. Okay. So yeah. Yeah. So let's say I have a vector. Let's say I have a vector A, which is 4i, right? So,
Yes, sir.
so Nabila, you tell me what is the negative vector of this vector? Right. So negative vector of this vector. So Akif is raising.
I don't know, sir.
You don't know. Yeah. So Akif, tell me what is the negative vector of this?
-4 I cap.
Right. So minus 4i. Nabila, did you understand this? Yes.
Okay, yes, yes.
Yeah, because for the negative vector, we know that the magnitude should be the same, right? And the direction would be just the opposite. So this is I hat direction. So what is the opposite of this I hat? So this is I
Yes,
hat.
sir.
The opposite of this is minus I, right? So the magnitude of this vector is how much? Nabila, what is this? What is the magnitude of this vector?
So can you explain again the internet issue?
Yeah. So you have this vector 4i, right?
Yes, sir.
You have this vector 4i. And what is the magnitude of this vector? What is the magnitude? Which part represents the magnitude? This part, right?
Yes.
So magnitude is 4, right? And the direction is I. Okay.
Yes, sir.
So if I want to write the negative vector of a vector, so magnitude is 4. And what is the direction? What would be the direction? The opposite of I. So opposite of I is how much? Opposite of I.
Minus I.
Minus I, right? This is I, and this would be minus. So minus I, so this would be minus 4i. Right? This is the negative vector of, let's say, let me write it as but this is actually minus a, so b, which is minus a, which is this. Right. Now let us understand if we have, so let's say that we have this vector r, which is 3i minus 4j. Okay. So if I want to write the negative vector of this, so what would be that? R negative. What would be that? Yes, Nabila.
-3 I
Yeah. Yes, minus 3i.
I cap plus 4 J cap.
Yes, correct. So not negative would say, yeah, yes, Nabila. Yes. So did you say minus 3i plus 4j?
Yes, sir.
Yes. Yeah. So yes, absolutely correct. So R negative would be simply minus of 1. Right. So that is how we can calculate the limit. Okay. Understood, guys?
Yes, sir.
Now,
Yes.
so this part I have already, so we have already learned with this archive, but let me tell you about this.
Okay, sir.
Yeah, so we now know that we can represent any vector like this.
Yes, sir.
Right,
Yes.
Nabila?
Yes,
Right.
sir.
Now, to represent, so vector has two important parts, right? Vector has magnitude and direction. Okay. Okay, Nabila.
Yes, sir.
So how will we find the magnitude
Yes,
of
sir.
this vector? Right, this is the purpose. And what would be the direction of this vector? So to calculate the magnitude, so this is defined like this. So this is ax squared plus ay squared plus az squared. Right, so just note down this part. Okay, now let us move down this part. You have this a vector, which is this. So this would be the
Okay,
magnitude.
sir.
And the next question would be how to calculate the direction. Okay. So did you note down this part? Nabila? Yeah, you got, yeah, you are. So did you note down this part? Nabila? Yes. Akib, am I audible?
Yes, sir.
Okay, so maybe she is facing some incorrect issue. Yeah. Maybe the mind or maybe the network is. Okay, so let me go ahead. Right. So we can calculate the direction of the vector. So the vector has two parts, right? This magnitude and this guy, this unit vector. So this guy represents the direction,
Yes, sir.
right? So we can calculate. So now what is happening that we know this part and we know this part. So we know this vector and we know this magnitude, right? So what we can do is that we can calculate the direction from here. So a hat would be a vector divided by this magnitude. Am I correct, Akhil?
Yes, sir.
Right. So this a vector we know this is axi hat plus ayj hat, and this is azq. Okay, and divided by its magnitude. This is the unit vector which represents the direction. So this is the direction. Understood, guys? So this is the magnitude, and this is the direction. Okay.
Yes, sir.
Yeah. So Akib, you have noted this earlier, right?
Yes, sir.
Nabila, did you please note down this part and then we will do some questions. Yeah. Yeah, no worries, no worries. Yeah, you know that that is why you are not. Yeah, so we plan. So we know that you are facing something. So no need to bother about. You can write it in the chat box that you have noted on. Okay, Nabila. Yeah, so please note down this part. And whenever you are done, please tell. So guys, this class would be of 1.5 hours. Okay,
Okay, sir.
because you guys are in senior secondary school, right? So we need to have more time to discuss about these topics. Okay, guys.
Yes, sir.
Yeah, Nabila, done. Let's Nabila, you can write it in the chat box. Yeah, so when the mic is not working, then we have some communication there. And then, so then this becomes more difficult. So I hope that you have just take the screenshot and then you can go up. Okay. So let's say I have a vector which is so let's say I have a vector which is 2I plus 4j, right? Then I'm asking that what would be the magnitude of this vector? So what is the magnitude and what is the direction? Okay. So Nabila, you tell me the answer because Akib already knew the answer. Yes. Okay, so Akib, what can we do because Nabila can't answer. So help her. Okay, so what would be the answer, Akib?
Magnitude will be
Yeah.
2.
2. How?
So 2I cap, right?
So we have this x component as well as this y component, right? And what is the magnitude?
So we should add both of them.
So this is ax squared, ay squared, az squared, right? Right, Akib?
Yes, sir. Yes.
So whatever is the x component, whatever is the y component, z component is 0, so we can leave that, right? Do we have a z component in there?
Root 20, sir?
Yeah, so 2 square plus 4 square. Yes, so root 20. Yes, correct, sir. What is why did you reply this 2 part? Right, you got confused. Yes, Akil.
Sorry, sir?
So you got confused, right? So
Yes, sir.
yeah, you didn't see this part, right? So yeah, so and we can simplify this root 20 because this is 4 into 5, right? So this is 2.
Yes.
So 2 root 5. So this is 2 root 5. This is the magnitude. Okay. And what would be, so can you tell me about this direction as well? What would be the direction?
Direction. I cap plus j cap.
Think again, sir. So what is this direction?
Direction will be I k cap plus j cap.
So just we have just learned this, right? This direction is this vector divided by this magnitude, right?
Yes, sir.
So whenever you don't know the answer, just think that what is given. So vector is given and the magnitude is given, right? And we know that this vector is dependent upon this magnitude as well as this direction, right? So this direction would be simply division of this vector with this magnitude, right? Okay.
Yes, sir.
Yeah. So this vector would be this direction would be simply what is this vector and divided by its magnitude. Okay, waiting on. So did she get disconnected at some point?
Yes, sir.
Okay. Yeah, again network issues, Nabila. Yes. So don't worry about this network issue, right? So yeah, so did you were you there when we were discussing this problem, Nabila?
What's up?
So yeah, so now you might be, yeah. So you understand this problem, right? A vector is given
Yes, sir.
and we want to calculate the magnitude as well as the direction, right?
Yes, sir.
So just a few moments ago, we learned that we we can calculate the magnitude of vector like this, right?
Yes.
So this is how we calculate the magnitude of vector, and the direction part we know, right? So the direction we can calculate the by dividing the vector with this magnitude,
Yes.
right? So we have this vector, right? So what is ax here and what is ay here and what is az? Nabila,
AX is 2.
right?
AY is 4.
Right,
And AZ is 0.
right. Yes. So this is 0. Now we can calculate the magnitude of this vector, right?
Yes, sir.
So this would be ax square, ay square. This is 0, right?
Yes, sir.
So as Akib told us that this would give us this root 20, which is 2, right?
Yes, sir.
And what would be this direction? So the direction would be vector divided by this magnitude, right, Nabila? So how much that would be?
2i cap plus 4j cap whole divided by 2 root 5.
Yes, this is divided by 2. Okay, Nabila, understood.
Yes, sir.
So this would be 2i divided by this 2 root 5. And then this 4j divided by this 2 root 5. Okay, so this 2 will cancel, this 2 cancels. So we have this I by root 5 and then this j by root 5. Okay, but this root is in the denominator, so we should do what? Akib and Nabila.
We should rationalize it.
Rationalize it, right? And how do we rationalize this denominator? So we multiply it by the same quantity, right?
Yes, sir.
And this is, so root 5 becomes what?
5.
5. So this is root 5 by 5 I hat plus root 5 by 5 j. Oh, this is 2, right? So this is
Yes, sir.
2 root 5.
Yes.
Okay, understood, Nabila.
Yes, sir.
So please note down this part, and then I will give one question, and then. So, Akib, sorry, this is repetitive for you because so Nabila has just joined, so then I am just repeating what we have done, right?
Yes, sir.
So please just be ready as well. Okay.
Yes. Okay.
And this would be also a revision for you, right? So
Yes, sir.
okay, Nabila, whenever you have moved it down, please tell me that. So I can scroll down this screen and then we can.
Okay, sir.
Done.
Yes,
Okay.
sir. Can just close it.
Oh, yeah.
Done, sir.
Done. Okay. Yeah. So let's say you have a vector. Okay. So now you guys know that. Let me do one more question and then we learn about this next one. So 3i minus 4j plus 5. Okay. So Nabila, you have this vector, right? You tell me what would be the magnitude and the direction of this vector. Yeah. So please do that and tell me. Or let us do here step by step. So what would be the magnitude of that first? What is AX?
3.
3. AY is how much?
-4.
-4. And AZ is how much?
5.
5. So what would be this magnitude?
Magnitude.
Yes, root of, right.
Yeah. Root of
of-
ax square
Yes, yes.
ay square plus ax square.
Right. This is the magnitude. So AX we know this is 3 square. And this is minus of 4 square, which is 4 square, right? Because minus of square is positive. And then you have this 5 square. So this would be 9 plus 16 plus 25. So this is 25 plus 25, this is 50. Right, so this is how much? 25 into 2. Right, so what would that be?
5√2.
Yes, 5. Yes, correct. So this is 5. This is the magnitude. And what would be this direction? Yes. Whenever somebody asks you about this direction, you just remember this. So just remember this. We have this magnitude and we have this. So just you remember this, then you will know the answer. So what is this direction? Yeah.
This is a vector divided by 3 vectors.
Yes. Yes. A magnitude. Yes. Correct. Right. Why are you hesitating? Be confident in your answer. Okay.
Yes, sir.
Yeah. So this is 3i 4j plus 5k and just y by 5. Okay. So you guys just calculate all that. Okay.
Okay.
Yeah. So just note down this part and try to solve it by yourself. Just note down this part, this question. Okay, Nabeel.
Yes, sir.
Yeah, so let me go ahead and just talk about this. So you have, so let's say you have a vector. So let us talk about this addition. I'm just quickly, so let me just quickly go. So let's say that you have this vector A, which is 3i plus 4j plus 6. And then you have this vector B, which is minus 2i, minus 2j, and minus 4. Okay. So A plus, so addition would be A plus B. Right. So this A plus would be 3i plus 4j plus 6k and plus of this minus 2i minus 2j minus 3. Okay, so this would be how much? 3i minus 2i is I hat. 4 minus 2 is 2j. And 6 minus 4 is 2k. Okay, so this is the addition of vectors. Right?
Yes.
Understood, guys?
Yes, sir.
So this addition of vectors follow the vector sum. Right? This doesn't follow this algebraic sum. Right, so this doesn't follow this algebraic sum. These addition of vectors follow this, not this. Okay, guys.
Okay.
And then you can, yeah, and then you can calculate this magnitude. So what would be the magnitude, Akif, of this resultant vector? Yes. Magnitude of
2,
R
sir.
would be 2.
Yes, sir.
Why 2 again? So this is
√5.
root 5. Okay. So root of, let us do step by step. So root of ax square, which is 1 square, right? Plus 2 square and plus 2 square. Right, Akib?
Yes, sir.
So this would be 1 plus 4 plus 4, right?
Yes.
So this would be root 9, which is 3, right, Akib?
Okay, sir.
Right. And then we can calculate the direction also. So the direction would be simply r vector divided by this r magnitude. Okay, so this would be I plus 2j plus 2k and divided by this 3. Understood, guys?
Yes, sir.
Okay. So, Nabila, did you understand this part?
Yes, sir.
Yeah. So, what should so just note down this part, and then I will give you guys some homework, and then we can. Okay.
Okay, sir.
So just note down this part. So whenever you guys finish showing, please tell.
Yes, sir.
Done. So Akib is super
No, sir.
fast.
No.
Okay. Oh,
Little
so
bit
he's-
left.
ah. Yeah, Akib, please remember the components, right? So
Yes,
whenever
sir.
you are calculating the magnitude, so be careful with these, right? So they follow this vectors and right. So you have to be careful. Okay.
Yes, sir.
Done, sir.
Done. Akib, done.
Yes, sir. Finish.
Yeah. So let me give you a simple question. Let's say you guys, so let's say that A is 2i plus 4j minus 3k, and you have B, which is 4i plus 3j plus 2k, and then C is 2r, let's say 3i and minus of 4j and plus of k. And then let's take also this t. So this is 2i plus 7. Okay. And then you guys need to find, so find the magnitude of, let's say, S, which is A plus 5B and plus 2D and 2C and minus of 3D. Okay, guys, understood the problem.